This is AP Calculus 1.8, the squeeze theorem. The squeeze theorem is really common sense. It takes three different functions and graphs them. And they're telling you in the squeeze theorem that for your three functions, the h function is always less than the f function, and the f function is always less than the g function. So that means that the f function is between these two functions. So it says for all x in the open interval containing c, if the limit as x approaches c of h of x is L, and the limit as x approaches c of g of x is also L, then that must mean that the limit as x approaches c for f of x is also L. The reason that happens is because all three of these functions are ending up at the same spot at your c value, right here. So if for the g function that limit is at L, and the h function that limit is at L, and you know that the f function is always in between those two functions, then that must mean the limit of the f function as x approaches c is also L. It's really kind of common sense because that f function that you're told is always between the two functions. The g function is in red, the h function is in green, and you can see that that f function in black is always in the middle of those two other functions. And so it just makes sense that if they all kind of go into one single point at some place on that graph, and you know f is always between g and h, then at that specific point those limits must be the same. And that's pretty much it for the squeeze theorem. Here's a real quick example of the squeeze theorem. They're giving us that the function g is always between the f function and the h function. And then they give us the equation for the f function, and they give us the equation for the h function. And then they ask us to determine the limit as x approaches 2 for the g function, and they don't give us any numerical values for that g function. But since they did tell us that the g function is always between the f and the h function, as long as the limits at 2 are the same for these two, then you know the limit for the g function has to be the same because it's always in between those two functions. So for this one, if you find the limit as x approaches 2 of the f function, if we just plug 2 in, so the limit as the f function approaches 2 is -1. And then if we plug in 2 here, we have the limit as x approaches 2 of the h function. That would be cosine of pi over 2 times 2 is pi. Cosine of pi, again here, is also -1. So since these two limits are the same, then since g of x is always between those two, and their limits are the same at x equals 2, or as x approaches 2, and their limits are the same as x approaches 2, that means, by the squeeze theorem, that the limit as x approaches 2 for g of x is also -1.